you who invited me here, because I didn't know I had anything to say about this stuff. I have a sort of an interesting, I suppose, connection on all of this, because I spent a lot of my life focused on being an applied mathematics modeler, developing mathematical and computer models for various problems in mechanics. And then throughout the second half of my career, I switched over to very much taking an interest in the education of students in these matters, and eventually to the education of teachers. And so it's kind of like a sort of 2-minute summary of where this went, and that is the area that I worked in applied mechanics was that of fracture mechanics, how things break. And I worked on various areas, why would a wing fall off a plane if there was a crack on it, or why, and some critical sort of stuff here and there. But the one area that I began to get very involved in was the breaking up of glaciers. So I started looking at glaciology and the fracture of glaciers. How does ice break? So, sorry, just thought of an nasty pun there about breaking the ice. But, but essentially, it's called the calving of glaciers. In other words, a crevasse appears in a glacier, maybe 3,000 feet up on the side of a slope, and that slides down the side of a mountain. And eventually, when that place where the crevasse is reaches the sea, the big chunk of ice falls off. And of course, that makes an iceberg. And we all know what happened to Titanic. So, you know, that's important, and it was important in 1912. But of course, it's the melting of icebergs, as many of you scientists will know, is partly contributing to the rise in sea level. But of course, it's also interestingly contributing what happens to water when you put ice into it. It makes it colder. So it's actually making colder water, so which in some sense can create minor increases in temperature, and it affects, I come from the southwest of Ireland. It rains all the time. Why does it rain all the time? Because there's a warm wind from the Atlantic, the whole Atlantic cycle. There's some fancy word that someone else reminded me of again about, what is it, that cycle of the water going around. The what? Yeah, there's some other word as well. The Gulf Stream, that's right. Spending half my life influenced by the Gulf Stream, I should really remember. All I know is that it always came from the southwest. And so, but if you make enough cold water in a different place, it could actually alter that. So that's a kind of a strange unintended consequence. And as I said, I'm sure there are other people know more about that. But I spent a lot of time working on that type of thing. And then I began to get into sort of educational work. And I would visit schools, and I would talk to kids about, I do my research, or I'm a mathematician, I do numbers, and I do statistics. But the only thing that seemed to get an awful lot of interest is when I started talking about the iceberg. People were actually interested in it. So as I began to talk to kids and to see what we would do in schools, I thought one thing, there are probably very few people educating teachers who happen to have a sort of a background in applied mechanics. And so it was a kind of a strange engineering background. So I sort of said, how can I bring some of this kind of background into the education world? And I ended up eventually working with developing little modules, activities to simulate glacier type of things. And we turned them into, we called them integrated math science lessons in the middle school. And we ended up editing a book on this type of stuff. But I have devoted a section in that to the actual study of ice and glaciers. And it's, some of the simple experiments, there's the classic physics and math experiment where you just put a piece of ice into water and just look at the level of the water and how much, and there's a wonderful proportion problem, how much ice is under the water and how much ice is over the water. And it's always quite surprising. Is it only something like 1/10 of the ice is all you can see? There's an awful big, which I suppose is what happened to Titanic again. There was a lot more ice than they expected. And so, But we have little experiments like that, and there's one, this was a kind of a fun one where we have kids, if you like, watch a glacier. So they kind of create a big chunk of ice and they have to put it in the fridge, and when we come back next week, they have to leave it out for a bit, and you try and put a crack in it and you try and watch it slide down a slope. But it attracted a lot of attention, and what I found is that there are the related activities then, because you have to understand different aspects of science in order to understand that. But I think actually modeling a little mini glacier in a sort of a lesson plan gets kids actively involved in doing something. And I have, as I said, moved away into the world of doing a lot of more direct mathematics, teacher education, and that type of thing. But every now and again, some story comes up that kind of reminds me of it. And many of you may have seen about 2 or 3 weeks ago that there's a huge chunk falling off the Antarctic, you know, and I suddenly realized that's the stuff I was modeling, because they actually showed a picture of this huge fracture. Now, I can say that my little piece of computer code could measure a 17-mile fracture, but there's some kind of a scale thing going on there, and you can refer back to it. And there's another story that got me as well, because I often, some scientist unfortunately passed away because he fell into a crevasse in somewhere, I think might be Greenland or somewhere. These are dangerous things. You know, I have friends who lived on glaciers, and they said the noise is amazing, you know, that you can hear it constantly moving, cracking, opening. And the problem then is if you get fresh snow and you have this big opening and you don't know there's an opening, and it can have catastrophic consequences. But this is obviously, as we know here, it's a live and important prospect. And my issue then is to try and bring that through mathematical models to middle school kids or to somebody like that. So the only other thing I would say sort of it, and I said, I haven't been doing a lot of this in education right now, is that I also feel like that I happen to be a runner and a semi-vegetarian and all those things. So some kind of, I don't know, coaching, mentoring, personal life that we want to exhibit the need to save the environment. I currently keep my house at 59 degrees, and there's a lot of people shivering and thinking this is intolerable. So I can take off my jacket in this building. Thank you all.